So here, continuation of nucleophilic substitution reactions. So you know that nucleophile, it donates its pair of electrons to carbon, because here carbon acquires positive charge and halogen acquires negative charge. And when it donates its pair of electrons and it make a bond with the carbon at the same time, and you know carbon is having 4 bonds, so that's why if it is attached here and carbon will have 5 bonds, so that's why one bond should break, and X here X will be means halogen bond break and it will remove as a X minus. Clear? So in this case, and the nucleophile on which compound attacks, and that compound we will call as a substrate. So nucleophile attacks takes place on which carbon? Alkyl halide. So that alkyl halide we will consider it as a substrate. Clear? And this, you know, Nu minus means it is a nucleophile. It is a nucleophile. Then you know this, it is a product. It is a product. And here the halogen, it leaves along with its pair of electrons and converted into halide ion, and it is removed as a halide ion called as a leaving group. It is called as leaving group. Clear? Means in nucleophilic substitution reaction, what takes place here? A nucleophile attack on alkyl halide. Then this is, you know, that is the nucleophilic substitution reaction definition. And a nucleophile replaces already existed nucleophile in the compound, and that we will call as a nucleophilic substitution reaction. And these nucleophilic substitution reactions of alkyl halides have very importance. Why? Because by using these nucleophilic substitution reactions, we can prepare a number of compounds. Clear? So what are those? And we will discuss here one by one. So first one here, reaction with aqueous KOH or aqueous NaOH, means alkyl halide reaction with aqueous KOH or aqueous NaOH. Clear? See, we can prepare a number of compounds. See how it will be. And I will write here, alkyl halide reacted with aqueous KOH or aqueous NaOH and produces alcohol. See what is that one? Suppose I will write here alkyl halide and you know aqueous KOH. Then just heat it, and what you will get? And KX will be removed and OH will be added to R. So it is bonded. So ROH plus you will get the KX. Simple example, take here alkyl or ethyl bromide and treat this one with the KOH. Then what the compound you will get, and what we can remove here, KBr remove, and CH3 CH2 and what left here? OH. So you will get CH3 CH2 OH plus what it is? KBr. You see, this is alkyl halide and these are what? Alcohols. Yeah? Alkyl halide when treated with the aqueous KOH, and what we are getting here? Alcohols. Clear? And this is one reaction. What is the nucleophile here? In this case, nucleophile is OH minus. Clear? You know that here Rx is there. We have taken alkyl halide, and KOH. KOH means what it is? K plus and OH minus. You know, nucleophilic substitution reaction we have already discussed. OH attack here, X will be removed. Then what we are getting here? ROH plus X and K. X minus will be removed. So K plus, you will get the KX. So what is the nucleophile here? OH minus. Clear? Next one. This is the first one. And the second one is here reaction with water. Alkyl halide reacted with the water and produces here also alcohols. Okay? See now, same reaction. Take the RX plus water, H and OH. Shall I write this is? Just heat it. Then what the compound can we remove? HX. Remove HX and you will get the ROH plus what it is? HX. Simple example you take. and CH3, CH2, Br and HOH, and you know heat, then you will get the HBr and CH3, CH2, OH plus what you will get here? HBr. So what is the nucleophile in this reaction? What is the nucleophile? The nucleophile in this reaction is water, not OH minus ion. Because water, it cannot easily dissociate it into H plus and OH minus. Suppose see the what is the reaction. You know Rx, and here what it is? H2. H2O means it is having lone pair of electron, and then what you will get? Added here, then this bond will break. Then what the compound you will get? You see, you will get the compound is R and O and H and H. Here which one is losing electron? Oxygen. So that's why positive charge, and here. Now which one is removed here? X minus. This X minus will take the H plus here. These bond electrons will move towards the oxygen. So oxygen is gaining electron, H is losing electron. H is losing electron means it removed as a H plus, and here what is there? X minus. H plus and X minus, and bond formation takes place, HX will be removed. Then and on the oxygen positive charge is there. Now oxygen is gaining electron means which charge we acquire? It's a negative charge. Positive charge, negative charge on the same atom, and charge will be neutralized. So what you will get the compound here? ROH plus what it is here? X minus and H plus you will get here HX. So what is the nucleophile here? H2. What is the nucleophile here? H2. So that's why these are two reactions. In the two reactions also what we are preparing here? Alcohols only. Next one. Third one is reaction with moist Ag2O, silver oxide. Clear? What it is? Moist means, and it is reacted with water, H2. Then what it is? Moisture. Moisture means what it contains? Water. So that's why it converted into AgOH. Means if it is reaction with moist Ag2O means it is a like silver hydroxide. Clear? Now treated this one Rx plus, and here moist H2O means what I can take here? AgOH, and converted into Rx here. Then what the compound you will get? This is AgX and ROH plus AgX. What we have prepared here? Here also we are preparing alcohol. Clear? Take the one example. Any example. I am taking common example always, and CH2Br and AgOH. Or you can write here moist Ag2O. Clear? Then what the compound you will get? Remove here AgBr, and OH is bonded with CH3 and CH2 OH plus what you will get here? AgBr. Precipitate you will get. Clear? What is the nucleophile in this reaction? The nucleophile in this reaction is OH minus. Here Ag plus and OH minus. So what is the nucleophile here? OH minus. Clear? Next one. And the fourth one is reaction with sodium or potassium alkoxides. Very important. This reaction is called as Williamson's reaction. Very important. Alkyl halide reacted with sodium alkoxide in presence of ethanol, means that is a solvent. So you will get the ethers as a product. Clear? So see what is the compound? Rx plus sodium alkoxides, and this is NaOR. This is we will call as sodium alkoxide. Alcohol you know, ROH. Remove the H and replace that H is replaced by the sodium, then we will call it as a sodium alkoxide. This is called as sodium alkoxide. In the presence of alcohol, ethanol, it is a solvent. Mostly we will use the solvent is ethanol. Why? Because alkyl halides and the reagents will easily dissolve in ethanol. Clear? So that's why what the compound you will get? Remove NX here. Then what the compound you will get? ROR. This we will call as ether. What it is? Ether. Plus, and you will get NaX. And take the example CH3, CH2, Br plus NaOC2H5. NaOC2H5. What it is called? Sodium ethoxide. Sodium ethoxide. 2 carbons means ethoxide. And ethanol here. Ethanol here. Then remove which one here? Na here. Then you will get the CH3 and CH2O and here C2H5. It is C2H5. This is also C2H5 plus NaBr. What we will call here? Diethyl ether. What it is? Diethyl ether. So this reaction we will call as a Williamson's reaction. Very, very, very important. And remember here, later we will discuss, this reaction follows SN2 mechanism. Clear? SN2 mechanism. And we will discuss later what is that one. And in this case, what is the Williamson's reaction means? Alkyl halide reacted with the sodium alkoxide in presence of ethanol solvent gives ether, and that reaction we will call as a Williamson's reaction. Follows each mechanism here? SN2 mechanism. What is SN2 we will discuss later. Next one is reaction with dry Ag2O. Previous we have discussed moist Ag2O. In that one, alkyl halide react with the moist Ag2O, we got the alcohols. But here what it is? Dry Ag2O. And when alkyl halides, actually 2 moles of alkyl halides reacted with dry silver oxide and produces here 2 produces and ethers ROR plus 2AgX. Okay, simple. What is this reaction you see? So this is Rx, and here also how many moles we have taken? 2 moles. And Ag2O. Ag2O means, shall I write Ag2O like this? Same, I am just writing how it is. Clear? So what we can remove here? Agx, you see here. 2 moles of Agx we can remove. Here Agx. Clear? 2 moles Agx we got, and ROR, that is only I have written. So what I have written here? ROR plus 2 moles of Agx. So what we got the product here? Ethers. One is previous Williamson's reactions, there also we got the ethers, and reaction with the dry Ag2O also we got the ethers. Simple example, shall I take CH3 and CH2 Br, take the 2 moles, and Ag2O dry, it should be dry. Dry means there is no water, so it won't be converted into alcohol, means it won't be converted into AgOH. So that's why you will get the compound is 2 moles of CH3 and CH2O and, sorry, not 2 moles here, CH3, and here also you will get CH2 CH3, means you will get the diethyl ether, plus what you will get here? 2 moles of AgBr. You will get the 2 moles of what it is? AgBr. Clear? So this is the reaction with dry Ag2O. And last, here another one. Reaction with sodium hydrogen sulfide. Reaction with sodium hydrogen sulfide. Clear? What is the in this one? Clear? Next one, reaction with NaOH. So Rx plus NaSH. Then what the compound you will get here? You will get the compound, remove just the NaX, and what you will add here? RH. What we will call it is thioalcohols. What we will call here? Thioalcohols plus what it is? NaX. Simple example you take CH3, CH2 and Br plus NaSH. Sodium, what we will call this is? Sodium hydrogen sulfide. Sodium hydrogen sulfide. then what the compound you will get? NaBr remove here, then you will get the CH3, CH2, and you know in this case SH plus NaBr. These we will call as thioethanol, ethyl alcohol. We can say thioalcohol. What it is? Thioalcohol, thioethanol we can say. So this in this one, what is the nucleophile? In this one, what is the nucleophile? The nucleophile is SH minus I.